Hello dear friends, welcome my channels. I am talking about black hole and general relativity. General relativity equals to theory of gravity. General relativity simple word theory of gravity. General relativity is often quite different gravity, space, time, curvature. Whatever that means, matter tells space-time how to carve space-time tells matter how to move. That a very pretty summary, but it does not sound very much like the Newtonian world. That general relativity is also supposed to describe relativistic space-time descriptions of gravity. Relativistic space-time description of gravity as space-time curvature that will give us remind the viewpoint of gravity as a force. Newtonian viewpoint. We know that m into d square x divided by dt square is equal to f equals to m g. Now I write it is the function of x, and m I give a subscript g and I give a subscript I. So mi put a subscript I on the end because this is called inertial mass. Inertial mass. And I put a subscript g in the m. This mass is called gravitational mass. In fact, is the foundation for Einstein equivalence principle, very key ingredient in his theory of relativity and in the derivation and comprehension of the Einstein field equation. This g vector field, every point in space has a gravity field produced by the sum of all masses in the universe. And what is this gravity flow? The content of general relativity is the matter tells space time. Content of general relativity is that matter tells space time. So mg gx here, this is the gravity field. Gx is gravity field. Gx is gravity field, and gx equals to minus summation I capital G m I x bar minus x bar I minus and divide by x bar minus x bar I whole cube. And this is the distance between xi and x is the distance x bar. X bar is center of gravity. Gravitational potency. Gravitational gravitational potential. Potential phi x. Phi x equals to so friends, whatever we know, that d square x divided by d square equals to g equals to minus nabla phi, and this portion is nabla equal to, it can be written this way, del phi divided by del x cap plus del phi divided by del y cap, and del phi divided by del z into z cap. Laws of gravitational integral from gravitational integral form. That is phi x bar equals to minus g integration rho x bar dash d cube x dash divided by x bar minus x dash bar mod where x bar, this is the body, and x dash, x bar dash is here and x bar is here, and distance is, this distance is called x bar dash minus x bar. Differential form equation. This is the differential form, differential form. Differential form is nabla square phi equal to 4 pi g rho x bar. Now it can be written this way, del square phi divided by del x square plus del square phi divided by del y square plus del square phi divided by del z square. 4 pi g rho x bar. Freely falling bodies move along space-time. Freely falling bodies move move a move along space time, that is x superscript mu lambda, where mu belongs to 0, 1, 2, 3 is the 4 dimensionals. Schwarz matrix might be r coordinate. Schwarz matrix might be r coordinate and so on. So this describes the path that a particle takes in 4-dimensional space-time, where lambda varies along the curve. It is analogous in the Newtonian case. mg g bar x equivalent to x bar t, coordinating itself, so we can't use time as the variable parameterizing occur. A geodesic is nothing more or less than a curve of extremal, that is tau equals to integrations summation nu g mu nu x into dx mu divided by d lambda and dx nu divided by d lambda whole to the power half into d lambda. Now the path is A is point and B is point, and this is the path. So tau is equal to A to B summation mu and summation nu g mu nu x into dx mu d lambda and dx nu divided by d lambda to the power half into d lambda. Very simple equations. So the proper time that it takes to go from point A to point B in space time along a curve. The curve is a path parameterized path. So I have point A, point B. I have some path from A to B. In fact, means the path of maximal proper time, which may be the path of shortest spatial distance. On it may not there's some path from A to B, part of it takes. The equation is and then we can compare it, this formula, friends, d square x mu, d square x mu d tau square equals to minus half g superscript mu nu and del g beta gamma and del x alpha plus del g alpha gamma divided by del x beta minus del g alpha beta divided by del x superscript gamma into dx superscript alpha d tau and d superscript beta divided by d tau. So friends, we can write d tau square in this way. D tau square equals to g 0, 0 d x 0 whole square plus 0, 0, 1 d x 0 d x 1 plus up to, there are 16 numbers in here that can be arranged into a 4x4 matrix. Called the matrix of metric coefficient, on simply the matrix. When Einstein first wrote down this equation all about 1916 or so 1919, before the he got the fuel equation, he already introduced what we call Einstein summation notation, that just does not bother writing down these summation symbols. Here second derivative of the now space time position using proper time instead. This equation really say that if gravity is the only force acting on a body, that body will take a path of maximal proper time going from event A to event B, and it really is maximum if it's a massive body. If I look at events that are not quite coincident. Suppose a particle takes for a nearby event and then maybe goes to some other final event, like this kind of, this is this way. A particle takes for a nearby event and then maybe goes to some other final event, like so. This like so. Adjacent geodesic, these are parts of extremal space time. Adjacent, this is the adjacent geodesic, these are paths of extremal space time distance in a curved space time. Geodesics may start out parallel but then diverge, or they may start out parallel and converge. For example, on a sphere, suppose that you start on the equation at 2 points that are nearby on the equation but not coincident, and you take the straightest possible paths then that you can for each trajectory going due north and everyone. Now, Einstein field equation. Einstein field equations is G mu nu is equal to 8 pi G T mu nu, where G mu nu is Einstein. This is Einstein tensor, and this is gravitational constant. I am going against the philosophy of exploring black holes book by including Newton's constant, but I do it for comparison with Newtonian equation of gravity, where we explain a little bit about that a moment and then 8 pi. Schwarzschild matrix is exact solution to the Einstein field equations. Einstein field equation that describe the gravitational field outside a spherical mass on the assumption that the electrical charge of the mass angular momentum of the mass and universal cosmological constant are all zero. So friends, Schwarzschild metric is the most general spherically symmetric vacuum. So our equation of the Schwarzschild matrix is G equals to minus C square into D tau square is equal to minus 1 minus Rs divided by R into C square dt square plus 1 minus Rs by R to the power minus 1 d R square plus R square d G dt square. capital omega. This is the equation. This equation is called Schwarzschild metric equations. The solution is a useful approximation for describing slowly rotating astronomical objects such as many stars and planets, including Earth and Sun. In general relativity, Birkhoff's theorem states that any spherical symmetric solution of the vacuum field equation must be static and asymptotically flat. So again I repeat that in general relativity, Birkhoff's theorem states that any spherically symmetric solution of vacuum field equation must be flat, must be static and asymptotically flat. So we get, that's why we get this kind of equations. These equations is Schwarzschild metric equation. Here G omega is equal to d theta square plus sine square theta d phi square, and here rs equals to Schwarzschild radius and equals to rs is equal to 2gm, g for gravitational constant, divided by m divided by c square. This is the Schwarzschild radius values, and omega is a point on the two sphere S square, and noted omega is a point on the two sphere S square. Phi is the longitude of omega. Phi is the longitude of omega around the chosen z axis. Now friends, we will discuss more about the Schwarzschild metric equations, but in this video I just summarize and introductions about Schwarzschild metric. And black hole radius is the Schwarzschild radius equals to Schwarzschild radius equals to black hole radius. Now I want to discuss about black hole. A black hole is a region of space-time. A black hole is a region of space-time where gravity is so strong that nothing, means no particles or even electromagnetic radiation magnetic radiation such as light can can escape from it. The theory of general relativity predicts that sufficiently compact mass can deform space-time to form a black hole. The simplest static black holes have mass but neither electric charge nor angular momentum. These black holes are often referred to Schwarzschild black holes. The simple static black holes have mass but neither electric charge neither electric charge nor angular momentum. These black holes these black holes are often referred to as Schwarzschild black holes. Schwarzschild black holes. Now this is the last portion, but very interesting topic, that Sir Ramanujan, Indian genius mathematician, mathematician Ramanujan, Sir Ramanujan's series also explain black holes formula. However, it is knowingly this series equations. This is the very interesting that without telescope, without any help, Sir Ramanujan invented some formula which explain black holes. That they are phi L Q equals to summation n equals to 0 to infinity minus 1 to the power n q to the power n square and q comma q square n subbase n and minus q to n. Psi LQ is equal to summation n equals to 0 to infinity minus 1 to the power n q to the power n plus 1 whole square q comma q square n divided by minus q 2n plus 1 and rho L Q equal to summation n equals to 0 to infinity q to the power n into n plus 1 divided by 2 minus q n divided by q comma q square n plus 1. Sigma L Q is equal to summation n equals to 0 to infinity q to the power n plus 1 n plus 2 divided by 2 minus q n divided by q comma q square n plus 1. So friends, this theory, this formula influenced black hole equations. Also, Ramanujan formula helped string theories. So friends, thanks for watching. This theory is very large, general relativity. One video can't express everything. So friends, if you feel if you like my videos, please watch and subscribe, and also and comment also. I hope I can create another videos and explore more and more based on general